Heritage Geometry students. Today we're going to start Chapter 4. Hope your Chapter 3 test went well. We are going to split this lesson into two different videos, so if at any time I'm going too fast, just stop the video, pause it, rewind, rewatch, do whatever you need to do to make sure you get your notes down. We will be checking your notes on Monday, so please make sure you're ready to go. So what we're going to be looking at is 4.1, applying triangle sum properties. A triangle is a polygon with three sides. That means they have to be line segments. And we name our triangle based off the vertices. Here we have a triangle with vertices M, R, and S. When you're naming your triangle, you can write out the word triangle, or since we are mathematicians, we're going to use a triangle symbol. So we're going to say triangle. I'm going to pick a vertice, and I'm going to go either clockwise. So this one could be triangle MRS, or I could go counterclockwise, VEN. You do not necessarily need to start with your top vertices. For this triangle, I could have called it EVN. I could have called it triangle ENV. Or I could have started with the vertice N. It's up to you, just as long as you're being consistent and going in order. We can classify triangles by its sides. We have three different names for three different types of triangles based off of its sides. We have a scalene triangle. That means no sides are congruent. A second option is an isosceles triangle, which has at least two congruent sides. And we know in this figure that we have two congruent sides because we have our hash marks indicating that those line segments are in fact congruent to each other. Our third option is an equilateral triangle. That means all three sides are congruent. We know this because each one of the three sides has a double hash mark saying that they are all congruent to each other. If you are an equilateral triangle, you are also an isosceles triangle because you have at least two congruent sides. Another option we have is to classify triangles by their angles. And we have four different ways to classify triangles by angles. It could be an acute triangle. An acute triangle has three acute angles. And acute angles are angles who have a value less than 90 degrees. A right triangle has one right angle. That means one of the angles equals 90 degrees, and we can tell that in the picture because of the box. The box indicates that that is the angle that's worth 90 degrees. If it doesn't have that box, we can't assume that it's a right triangle. Another option we have is an obtuse triangle. An obtuse triangle has an angle that's less than 180 degrees, but it also has to be greater than 90 degrees. And that angle is that one. Our fourth and final option is an equiangular. Equa, remember, meaning equal. Angular, meaning our angles. So we have three congruent angles, and we can tell all three of those angles are congruent because they all have the same marks. Here's an example. Classify the triangle by its sides. Then determine if the triangle is a right triangle. So the first thing we need to do is classify the triangle by its sides. And I have three vertices, A, B, and C. I don't know what that looks like, so I'm going to quickly just make a sketch of these. Here's my coordinate plane. Let's see, we'll make the point 2, 3. That's our point A. We have the point 6, 3. And 2, 7. So it looks something similar to that. And I don't know what the lengths of those are, but I can figure them out. I can find the distance of each of these because if we're classifying by sides, we're looking for sides that have the same measure. So I want to find the distance from A to B. So the measure of line segment AB, well, I can use the distance formula. The square root of the quantity of 6 minus 2 squared plus the quantity of 3 minus 3 quantity squared. So we've got the square root of 4 squared plus 0 squared. So the square root of 16 is 4. So segment AB is worth 4. I need to find the segment lengths of each of the other two sides. So AC, I want to use the distance formula again. So 2 minus 2 quantity squared plus 7 minus 3 quantity squared. So I have 0 squared plus 4 squared. Square root of 16, that equals 4. So it looks like these two segments are congruent, so I know I'm looking for at least an isosceles triangle, but we have to check our last side. Check CB. So we can take 6 minus 2 quantity squared plus 3 minus 7 quantity squared. And we've got the square root of 4 squared plus negative 4 squared. So that's the square root of 16 plus 16, and that's the square root of 32. But I don't want to leave it as the square root of 32 because there are perfect squares that go into it, so I can reduce it. 32 breaks up into 16 and 2. So 4 times the square root of 2 is my answer for the length of CB. So it's not an equilateral triangle, but we can say that triangle ABC is isosceles. And remember, when you're doing the distance formula, it doesn't matter which point you make your x1 and your y1, or your x2 and your y2, just as long as you're being consistent within the formula. So we've answered the first part of this question. The second part asked us to determine if the triangle is a right triangle. If something is a right triangle, that means we have a 90-degree angle. Well, by looking at my picture, I can kind of determine that it may be, and I can also help verify which angle I want to look at. I want to see if angle A is right. And if angle A is my right angle, that would mean that line segment CA would have to be perpendicular to line segment AB. And I know from chapter 3, if those two segments are perpendicular, their slopes will be opposite reciprocals. So that's what I want to look at. I want to look at the slope. So I'm going to use my slope formula, my change in y over my change in x, which was y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's find the slope of line segment CA. So 7 minus 3 over 2 minus 2. Well, that's 4 over 0. That's an undefined slope, and that makes sense because it's a vertical line. So if it is a vertical line for this one, I want to make sure that that slope of AB is a horizontal line, which would mean it'd have a slope of 0. So AB, the slope, change in y, so 3 minus 3, over 6 minus 2. So I have a slope of 0 over 4. So this is a vertical line. This is a horizontal line. So this is in fact a right triangle. And this is the stuff that backs it up. I can't just say yes because the picture looks like it. I have to back it up mathematically. So triangle ABC is a right triangle. with the measure of angle A equaling 90 degrees.